Welcome part 4 electroanalytical chemistry. We are continuing glass membrane electrodes. In next part 3 we are discussing the glass membrane electrodes. Today we are detailed discussions for glass membrane electrodes. The potential that develop at the surface of glass electrodes is called the membrane potential. Since that glass membrane at the tip is thin and potential develop due to difference in the concentrations of hydrogen ion on the opposite sides of membrane that cause the potential that membrane potential to develop. Ag or AgCl, it's a Cl or Cl plus or glass membrane and plus H plus. It's also this it's equations for Nernst equations. E is equal to E0 minus 0.05916 divide 1 log Cl minus plus 0.05916 divided by 1 log H plus outside divided by H plus inside. E is equal to Q plus 0.05916 divided by 1 and log H plus outside. Internal H plus is a constant. It can be combined with E0, which is so a constant giving a modified E0 or E star. Element eliminating H plus internal, E is equal to E0 plus 0.0592 log H plus internal. So additions we can recognize that pH is equal to minus log H plus and substitute this into about equations. E is equal to E0 minus 0.0592 pH. So two pH meter are connected. We are also discussing in part 3 that's glass membrane electrodes, so saturated Calomel electrodes and glass membrane electrodes. It's filling pots and solutions of unknown pH and magnetic stir, and also it's a glass membrane electrodes. It's a glass membrane electrodes 2 meters and the pH sensitive glass membrane, that's one is, and it's a porous wick and the Ag or AgCl reference electrodes, it's a sample and it's a porous wick and 0.1 molar HCl, that's one. Next is a reference electrode. So reference electrode is stable and has known electrode potential. Reference electrodes, it's a stable and known the electrode potential. Its remarkable stability in accomplished by the using the redox systems. This which it's which required the saturated concentrations in which of the participating solutions of reactions. So reference electrodes need to have a repeatable and steady voltage, and it's a reversible type electrodes are employed as reference electrodes. A tiny cathodic current in a reversible electrode was the reduction reactions, and various small anodic current cause the oxidation reactions. Next one is silver chloride electrode. Silver chloride reference electrodes is made of silver wire coated with a coating of silver chloride AgCl, which is then the submerged in solutions that is saturated with KCl or AgCl. Reactions in half shell is AgCl plus electrons and gives the AgCl, that's is separated. That is advantage is we are discussing the easy to produce and rapidly demonstrate potential and achieves the producible and equilibrium between 30 degrees Celsius and 135 degrees Celsius. It's a stable and accurate despite large temperature variations. And we are discuss next one is disadvantage. What is the disadvantages of silver and silver chloride electrodes? So silver and silver chloride electrons disadvantages is react to samples. It's a react to samples and saturated calomel electrodes. It's based on reactions between elemental mercury and mercury 1 chloride is known as saturated calomel electron CSE. Saturated solutions of potassium chloride in water serve as aqueous phase is contact with mercury and mercury 1 chloride. Since the electrodes is generally connected to fluid in with the water, electrodes is immersed via a porous bridge. It's a salt bridge. It's an example of salt bridge. So advantage is this entire pH range. So compared to silver electrodes and mercury and react with the pure samples and reliable electrodes. Disadvantages were discussed the high temperature coefficient and establishment takes longer and chloride ion solutions exhibit incompatibility. So next one is saturated calomel electrodes SCE. It's a saturated calomel electrodes is a half shell composed of mercurous chloride Hg2Cl2. Calomel is a contact with mercury pool and these components are either layer under saturated solutions of potassium chloride within a compartment surrounded by the saturated KCl solutions called double junction arrangement. Platinum wire is generally used to allow contact to the external circuit. The half reactions is described by Hg or Hg2Cl2 or KCl. This is the electron reactions in calomel half shell. Hg2Cl2 plus 2 electrons, 2 Hg plus 2 Cl is 0 is equal to 0.268 volt and E equal to E0 minus 0.05916 divided by 2 log Cl minus and is equal to 0.2441 and temperature dependent is a calomel electrode saturated with KCl is called to saturated calomel electrodes and CSE. Its advantage using saturated KCl is that Cl minus does not change if some liquid evaporates. Wirelets and PT wires hold to allow it's a porous plug that's an Hg and Hg2Cl2 plus KCl and it's a porous plug that's between side and the solutions that's a KCl and glass walls. Next one is reference hydrogen electrodes. The hydrogen electrodes serve as a reference to for the electrodes potential measurement. The theoretically, it is the most significant electrodes for usage in aqueous solutions in a solutions of hydrogen ions with unit activities. The reversible hydrogen electrode display a potential that is a rough to zero through the uh, zero at the all temperature. Next one is standard hydrogen electrode SHE standard hydrogen electrodes. The standard hydrogen electrode is the universal reference electrode for reporting a relative reference cell potential. It's types of gas electrodes and was widely used in early studies as reference electrodes and as an indicator electrodes for determinations of pH value. The standard hydrogen electrodes would be used as either an anodes and cathodes depending upon nature of half shell it's is used with. The consist of platinum electrodes immersed in a solutions with a hydrogen ion concentrations of 1 molar. Platinum electrodes is made of small square of platinum foil, which is a platinized hydrogen gas at a pressure of 1 atmosphere is doubled around the platinum electrodes. The platinum black serves as large surface area for the reactions to take place. The stream of hydrogen gas keep the solutions unsaturated at electrodes side. With the respect to the gas, and it's interesting to note that even through this SH standard hydrogen electron is a universal reference standard. It exists only as a theoretical electrodes which scientists use as a definitions of a arbitrary reference electrodes with a half cell potential of 0.00 volts. Because half cell potential cannot be measured, this is perfect electrodes to allow scientists of perform theoretical research calculations. The reason these electrodes can not be measured in due to fact that no solutions can be prepared that yield a hydrogen ion activities of 1 molar. Next one is standard hydrogen electrode. Its value is affected by temperature, pressure of any gases and solution concentrations. So hydrogen electrons is based on redox half shell and 2H plus and 2 electrons gives H2 gas. So redox reactions occur at platinized platinum electrodes. The electrodes is dipped in a acidic solutions and pure hydrogen gas is bubbled through its and concentrations of both the reduced from oxidized form of a hydrogen is maintained at unity. That's implies that the pressure of hydrogen gas is 1 bar and activity of hydrogen ion in the solutions is 1 molar. The activity of hydrogen ion in their effective concentrations which is equal to formal concentrations time and activity coefficients are also close to 1 for very dilute water solutions but usually lower for the more concentration solutions. It's a PTH2 and H plus. It's 1 half H2 or H plus or electron minus E0 equal to 0.00 volt. The standard hydrogen electrons is a difficult set up, so it's easier to choose more convenient secondary standard which has been calibrated against the SHE. Why the platinum? It's you need to inert metal to get the electrons in or out. Conditions temperature 298 Kelvin and solution concentrations 1 mole decimeter cubes and the reference sorry respect to H plus and hydrogen is 1 atmosphere pressure. Thank you. We are discussing in next part to be continue our series for electroanalytical chemistry.